Good afternoon. Welcome to the live interaction session for database management systems. You all know me. I have with me here Srijani and Himadri, the TOs that you may be familiar with. They are off the camera screen, so you are not seeing them, but they are helping us in the process. They will answer some of your queries offline if required. So, I will get started. We have collected all the questions. I should say that most of the questions that were put up, and we have prepared the responses for that. In addition, if there are questions coming online, I will try to answer them towards the end of the session. So, I will start with the first question. This is from Nirav. The question was, is SQL an example of procedural or non-procedural query language? One is, Nirav, this was discussed in the early stages of the course. Here we have given the reference. If you go to module 4, specifically slide 17 and around, you will find the answer to that. Yes, SQL is a non-procedural query language. So, it is also called a declarative language. The basic difference between procedural and non-procedural is a language like C or Java, C++, this is procedural. In a procedural language, we write out the steps that are required to be performed to convert the input into the output. So, in a procedural language, you kind of tell the system how to do the computation, but you do not really care to tell the system as to what exactly the result will be. I mean, you give the computation steps, the procedure, and whatever comes out given the input is taken to be the result. In a non-procedural language, typically in a declarative language, you do the reverse. You tell what you want as a result. So, you kind of specify that these are the properties that must be satisfied by the result that I want, and it is a responsibility of the system to find out what should be the procedure for getting to that result. So, in non-procedural, you specify what and how is actually derived from that, and in a procedural, you specify how to do the computation, but what may not be known to the system. I mean, it is actually not known to the system. So, SQL in that style, you will find that the most typical query like select from where specifies as to what you want. So, you are saying that I want the answer to my query from such and such table, that is a from. I want every tuple to exist in the output query, provided they satisfy the condition given in the where clause, where you know there could be really complex conditions that can be given. And finally, you specify in the select line as to these are the columns I want in the output. So, you are specifying as to what you want in terms of the result, and therefore, SQL is a non-procedural declarative language. I think that should answer your question. So, I move on to a similar related question. This is from Anushree Shah. Anushree has asked, why do we learn relational algebra and calculus? Do database engine internally converts our query to relational algebra or calculus form before execution? I mean, if you see, we just had a discussion on the procedural and non-procedural. Now, relational calculus is a basis for the language like SQL. So, relational calculus is in the style of a non-procedural or declarative specification. In contrast, the relational algebra is a mathematical specification of different extended set theoretic operations. So, relational algebra is in the style of the procedural specification, it tells you the steps. So, what happens internally is when we write some query, when we write a select from where, you can see an example here, we are writing select ename. Ename certainly is coming from the employee table, where ename must be an attribute. So, where salary is greater than 5,000. So, what we mean, get the names of all employees from the table who earn more than 5,000 as salary. Now, this directly finally, the system needs a procedure, a sequence of steps to compute. So, this is translated by the query compiler into an equivalent relational algebra expression. So, here as you can see, the var will get converted into salary being greater than 5,000, and the whole thing will apply on the relation employee, and from the result employee table may have multiple different fields, the multiple different attributes. I will do a projection to get the e name. On the right we have shown a schematic diagram for how this is represented. So, this is your guess is right. I think we have discussed it also in certain module, that the specification in SQL, which is a representation for relational calculus, will get converted into relational algebra, which is a procedural one. So, non-procedural to procedural transformation happens there, and then that query is subsequently optimized and then executed. So, in terms of why we learn them is certainly we need to know the basis for to be able to write queries. We need to learn SQL to be able to understand how SQL works or how SQL is specified. We need to learn about relational calculus, but the mathematical basis, the foundation of that lies in the relational algebra. So, it is easy to express in formal terms as to what the queries mean. So, we learn relational algebra and the necessarily the relationship between relational algebra and the relational calculus. So, referring to the earlier discussion, by learning them both, we learn in the process through which we specify what we want, and the automated process by which that what question is converted to how in the relational algebra. So, that is the reason we learn both. Of course, somebody who wants a very surface knowledge might get away by just learning the SQL directly, but that will impair your understanding of various other aspects of database, like how tables are represented, because those are all dependent on the relational algebra, how join is to be computed and so on, why join is expensive and so on. Those answers do not easily lie, or cannot be easily found in the domain of relational calculus. They are more difficult to understand in terms of logic formula, but they are far more easy to understand in terms of set theoretic operations like the relational algebra. So, that is kind of motivation behind going through these. So, here are some more illustrations of showing how queries are getting converted into relational algebra, which we have done plenty. So, I will change gear and move on to a question from Shubham Kumar. I think it was a rather elementary question, and Shubham, I am sure you have not been very thorough in terms of listening to the video and reading the lecture material, particularly module 4, where we have explained these concepts. So, as you have rightly expressed, out of all the attributes, F determines A and A in turn determines B, C, D, E. So, it is very clear that by the axiom of Armstrong's axiom of transitivity, F will determine all the attributes, and therefore, F uniquely specifies the values and it becomes a candidate key. So, this was quite trivial. So, how is the primary key selected? I think I do not know who has asked this question, possibly we missed to document that, but what surprises me is if you have gone through the modules and the lecture around this, then these questions are very thoroughly discussed and answered. So, primary key of a table consists of one or more columns whose data can uniquely identify each row of the table. So, and we have also discussed that actually given a table there could be a number of subsets of attributes or rather sets of attributes, one or more attributes, which will have this property of being able to uniquely identify each row of the table. If there are multiple, then one of them, these multiple keys are called the candidate keys, and one of them which is actually used in the design, so that it can be used in terms of deciding how we represent the physical data in the physical database in terms of B plus tree or in terms of indexing. So, that those decisions are made in terms of the key which is specified as a primary key. So, primary key necessarily is a candidate key. All candidate keys are not primary key, there is only one primary key, and out of the candidate, all of them have the property that they can uniquely identify each record in the table, not only the records that exist now, but the records that existed earlier or the records that can exist in future. In every case, they can be uniquely identified, and of the candidate keys, one specific key we designate as a primary key, and we implement and do all the subsequent procedures based on that. Again, there is a question on foreign key from Manibindu. Can you please explain the foreign key uses in more detail? We have already discussed that, but you are asking for some more detail. I think these were also discussed, that the purpose of the foreign key is to ensure referential integrity. So, what does that mean is, if I have two tables, and naturally between these two tables we have two tables. So, two tables must be representing two parts of information, two segments of information, and they are related. So, we have entities which are related. So, some part of the information is in one table and some part is in the other table. So, as we show here, that there is a table student which keeps the information about the students, the name, branch, there could be several others, roll number, etc. several. And there is another table which is examination, which says that which keeps in different subjects the marks scored by the student. So, these two will have to get related, because on one side you do not want, for all the different reasons of redundancy that we have discussed, you do not want all this information to be together. All this that will cause all sorts of anomalies. So, you have separated them. Students personal information like name, branch, etc. is in one table. Examination performance related information is in another table, but when I have these, I need these to be linked. For example, when I will finally print the result score sheet for the student, it is not enough to just say that what is the code for the student, or what is the code for the subject, and what is the score given or the roll number. I would also need the name of the student. So, I will need to relate these two, and so this relation is done through the use of keys. So, I have in student the primary key which uniquely identifies every record, which is roll number here, and I am using that in the exam table to link up the information from the student table. Now, note that in exam table, roll number is not a key, because a single student, a single roll number could have attended, or will usually attend multiple subjects, and will have different scores in them. So, as you can see that there are 2 instances of 1, 2 instances of 2, and 2 instances of 3 roll number in the exam table. So, but you know that this field roll number is actually a key, primary key in a different table. So, you know that there is another table student where this is a primary key. So, you want to use that information so that you can link up, so that you can efficiently search that information. So, you say that in exam table roll number is a foreign key, it is a key in some other table. So, that is the basic purpose. I will show you another example here, just that you understand it better. So, here the example is in terms of customer and their contact. Now, we have the customers, and they are uniquely identified by the customer ID, that means, and so that is a primary key in that. We have the contacts here, and against every customer ID we may have multiple contacts. So, you remember all the discussion that we had, that there could be attributes which have multiple values, the multi-valued attributes. So, a particular customer may have multiple phone numbers, multiple emails. So, we have to separate them out, so that we do not have data redundancy. So, a customer cannot have multiple names. So, that goes into the parent table customer, but the customer may have multiple contacts. So, that goes into the child table contact, and the linkage between them happen to the cust ID. Naturally, cust ID is a primary key in the customer table, the parent table, but in the child table it is a foreign key. So, it is not a key, but it says that given this value in this field, I can uniquely identify or uniquely relate a set of information in the customer key, which I would like to find out. So, that is so foreign key formally says that it refers to a primary key in some other table, and this is the purpose, this kind of linkage where you have done proper normalization of the database, so that the information that is not in multiplicative form is in one part, that information which may have multiple values is in another form, or multiple combinations is in another table, and you link them up through this primary key foreign key mechanism. I hope I would suggest that you again go through the video and the presentations on this. We have repeatedly tried to discuss this. VSS Archana Gorthi, you have asked for joint classification. I think we have discussed every type of this, and again in the video and the lecture and given examples. So, joint could be of multiple type, the outer join, inner join, natural join, the left outer join, right outer join, full outer join, equijoin when you look for equality of information. But please go through the slides, you will have more information, because just knowing what are the different types of join does not help. What you need to understand is why you do what, in what condition or in what situation you do perform which kind of join operation. So, here are some examples. Also, this is against a query from Avnish Dwivedi. So, Avnish, you are asking a very fundamental question: why do we use join? Again, I'm getting little worried that if you are asking this question, then you have not understood quite a lot of things in terms of the database design. Why we do join? The answer actually should go back to the fact that there are dependencies between fields. So, certain fields remaining same, certain other fields of related information may be different. So, when we try to keep them in the same table, we may have the fields which remain same will have across multiple rows, they will have the same value, and that is what causes all kinds of insert, delete and update anomalies. It is a major source of design pain. So, that led us to the issue of splitting this table designs in terms of the normalization process, so that in every table we have information which are closely related to each other, so that there is not possibilities of duplication of values between different records. And so, once we have done that, once we have gone up to that which is driven by the requirement of doing a good design, doing an efficient design, doing a design that does not easily violate the integrity of the database. The question is, if we have segregated the information in terms of two or more tables, how do we get the original parent information back? And that is the backbone of the whole design process, whole normalization process. So, join is the process through which you get the information back. So, you have two tables which have related information, and you have one or more fields which are common between the two tables. Using these common fields, you try to relate the information and build up what information would have been there if you had kept everything together in a single table. And whether or not you can do this between tables which has been segregated through the normalization process is decided by the lossless join property of the normalization. So, that is the kind of the whole story, and that story is a key, the central idea of the whole database, relational database design, and it is my earnest request to everybody to give a lot of attention to that. You must understand that well to perform well in this course as well as to become a good database engineer. Now, coming to the example on the board, as you can see that here we are talking about customers. So, there are different customers, they have customer IDs written here as CID, they have their name, the country they come from and so on. And there is a product table which has the information of different products, the product's ID, the name, the country, the product is a quantity available in the inventory, the unit price and so on. And now we want to model the situation that the different customers buy different products in different quantities. So, any buy of a certain product by a certain customer needs to have the quantity and will be called an order. So, that this basic information of who buys what in how much quantity will be recorded through a unique ID called the order number or the order ID. So, the third table is order ID, which maintains against the order number the month when the purchase was done, the customer ID that says who purchased it, and the product ID what says what was purchased and how much quantity was specified. So, you can see that the basic two entities of information, whether about the customer details and the product details, are kept separately, and it is only the order of who buys what, when and how much, this part is just the order and which kept as a separate entity. So, naturally you do not want the customer name to happen every time, because if C001 has done say like here 4 purchases, and if you would have kept the name or the country of the customer here, then those country would have been repeated 4 times. Similarly, a product has been purchased, say P01 has been purchased twice. So, if you keep the country of that product in that order table, then that will get remitted. So, all those issues. So, you have kept them segregated, and it is the key of the customer which is CID, is the key of the product table which is PID. Using those you create the order table. So, in the order table CID is a foreign key, PID is another foreign key, and this table has a unique generated key called order number. So, using that now you can answer different. For example, I want to find out that let me know all the orders which are ordered from the same country where the product is produced. So, it is a shipment issue, you will have to decide how to do the shipment. So, if say C001 who is from Essex county, if C001 orders a product P05 which is also from the Essex county, then I have a much simpler delivery problem to address. Whereas, if C001 in Essex county orders P03 which is from the Surrey county, then I have a longer delivery to be done. So, I might want to find out this information that tell me in the order which are from the order information as to what are the products that are produced and delivered in the same county, what are given to different counties. So, if I want to do that, naturally I do not have the county information of the customer or the county information of the product in the order table. So, how do I find out? I perform join, and performing join between order and customer, I can find out the county of the customer. Performing join between order and product, I can find out the county of the product, and then I can check whether they are equal to say it's a intra county delivery, and if they are not equal, I say this is a inter county delivery. So, these kind of answers can be provided, and that is the reason the only way to do this is join. Please understand join very thoroughly. I mean, they are the core of normalization and query answering, and particularly they are very expensive operation to perform. So, you need to really understand what kind of join will lead to what kind of back end computation in terms of the translated relational algebra expression and write the query in a smart way, so that your the query can actually be more efficient as well. So, there is a I think this is the there are several such reasons to using join and using it efficiently. We will move on. Data redundancy, I do not think that I should start with discussing data redundancy, because that is where we started the whole story about that. Data redundancy is a basic issue. So, please go back to those modules, those slides and those video, and you know there are three kinds of anomalies that can happen if you have redundant data, and this is I do not think this is a question that we need to discuss here, because then the whole session will discuss only this, but this has already been well covered. Moving on, this is a question from Nirav on normal forms, particularly second normal form. In order to, so you are asking, in order to decide partial dependency in second normal form, how to check if left hand side of functional dependency is combination of one prime and one non-prime attribute, right, where right hand side is a non-prime attribute. So, you are saying there is a relation having four attributes A, B, C, D, A, B is the key, okay, good, and then you have A, C determining D. So, if A, C determines D, so what is prime, what is non-prime? Okay. Now, A, B is the key, so A is prime, I know, C is not a part of A, B, so C is non-prime, right. So, we know C is non-prime and A is prime. So, A is not independently determining the other attribute D. So, it can do that only if is in combination with C, only then it can do that. So, it is not a partial dependency. So, there is no partiality in this, it needs additional information in terms of C to be able to determine D. Just think of, instead of considering A C determining D, if you are considering the partiality of A determining D, then it would have been a partial dependency, because A is a prime attribute and it can uniquely determine the attribute D. So, it becomes a partial dependency. You can refer to the slide and module again. I know partial dependence is a little involved concept, but go over the examples again, I am sure you will start doing better. So, here we have given some more examples. So, there is a table with registration number of or the roll number of student, course ID, the course name and the student name. So, naturally the primary key is the combination of the registration number and the course ID. So, they together decide the course name and student name. But independently registration number decides student name and course ID also decides course name. So, naturally both of these are partial dependencies, because on the left hand side what you have are prime attributes. So, this table design is not in second normal form. Let us take another example, student name, department and age. So, naturally in this the primary key is student name and department, that determines the age. Why do we need department to decide the age of a student? Because two students by the same name may be enrolled in two different departments. Now, this dependency also has an underlying assumption that in the same department at the same time there are not two different students with the same name. Now, given this, certainly this is the only dependency. So, there is this dependency is not a partial dependency, because the left hand side is all prime keys. So, this particular table is in second normal form, right. Okay. Now, let us move on to the next question, which is on B plus tree. The question is from T. Yamini Reddy. Can you once again explain the insertion and deletion of numbers in B plus tree? We have discussed that, but let me still try to do this once more. So, here what I show is a B plus tree which has a root and 4 leaf nodes. So, I am just taking a height of 2 to keep the example simple. And I assume that there are 4 keys that you can keep in every node. This is just a blind assumption, and in this situation I want to insert the value 60. So, if I want to insert the value 60, then what is the process? The process of insert is always 2 steps. One is if you want to insert, the first do a search with that value. So, if you do a search with that value, either you will find it and decide whether you still want to insert a duplicate or not. Possibly, if you are not inserting duplicate, you will not insert it. Otherwise, what is likely is once you try to find it, you will not find it, but you will find the position where this particular key would have been expected. Right. So, you do the find process. So, you start from the root. So, naturally within the root node 60 happens between 50 and 75. So, you follow the link in between them. So, it must exist since it does not match 50 nor 75, it must exist in the child which is pointed to by the in between values lying between 50 and 75, and you have 4 values 50, 55, 65 and 70, and naturally as you search within them you do not find 60, it is not there, but you figure out that it must go between 55 and 65. Now, if there were space in this leaf node, then you could have easily kept 60 there and your insert would have been completed, but there is no space here. So, what you will have to do? You will have to create space. Now, to create space, what you need to do is certainly you cannot create another child node, because in B plus tree the idea is always the height of the tree remains same. So, the only way to do this is to split this leaf node into 2 leaf nodes and distribute the keys equally between the 2 leaf nodes. So, the earlier 4 key values 50, 55, 65, 70 you split into 2 leaf nodes, 50 and 55 goes into one, 60 and 65 and 70 go into the other, and 50 becomes or remains the lead node lead key for the first split child, and 60 can now become the lead child of the second leaf node that is got created. So, once you do that, then naturally what you need now 60 becomes a new lead node. So, 60 needs to go in the parent, so that the new child can be linked. So, 60 goes in the parent and is placed between 50 and 75. Parent had only 4 nodes. So, only 3 values 25, 50 and 75. So, it has placed for one more. So, you insert 60 there and link up. So, that is the basic insert process. In case that you had to I mean if it was a case that when you try to insert 60 in the parent node or the root node, then already the root node had 4 keys, then you would have required to split that as well and create 2 different nodes. So, you would have required to convert the root in splitting into 2 internal nodes and create a new root node where these 2 nodes will get linked. So, that is the basic recursive insertion process. Deletion is so this is next is a deletion discussion. Deletion happens in a similar way, but for deletion it is naturally that the key must exist. So, your first process is to find. So, you do a find, you find 60 that you want to delete, and so you delete, but as you delete, then what happens? We check whether the 2 leaf nodes that are occurring side by side, whether they are adequately filled up or not, because unless they are adequately filled up, they do not need to exist separately, because you will have a lot of fragmentation in that process. So, you find that if you remove 60, the leaf nodes do not remain adequately populated. So, you merge them into one. As you merge them into one, then naturally 60 stops being a key that should exist in the root, because there will be no node whose lead value will be 60. The lead value of the merged node will be 50. So, what you will need to do is to merge these 2 leaf nodes and then go up on the root and also remove the key 60, which was pointing to the node that you are currently merged with its earlier node, and you will come back to this lower configuration. So, this is the two ways in which your delete insert and delete has to happen. So, to remember clearly, in both for insert and delete, the first task is to do a search. For insert, if you find, you skip any process. If you do not find, then you have found the position where the insert has to happen. If there is space, you insert. If there is no space, then you split, and as you split, you have new lead nodes which have to lead keys which have to go to the previous level. And so, the insertion starts at the leaf and then keeps on propagating up, and it can finally result that you need to do an insert in the root when the root itself is filled up, is already full. So, in that case, you need to split the root and create a new root. Delete again starts with the search process, and it must find the key to be deleted. So, you delete, and after deletion you check that is the node less full, I mean is it less than half full. If it is less than half full, then you try whether it can be merged with the adjacent node. If both are less than half full, then you can merge them together into a new leaf node, and in place of 2 leaf nodes, now you have only 1. As you do that, the node that you have sacrificed, the lead key of that node has to get removed from the parent node. And as you do that, by that process, the parent node may have become less than half filled. Then you have to do the merging at the previous level as well, and you have another key to remove from the earlier stage and so on, and it might eventually mean that you need to do a removal from the root as such. So, this is the whole process. Again, in the lecture and the presentation, we have tried to give more illustrations as well. So, please go through, you should be able to get it better. I did not really understand, Sanjeev, as to what you mean by how many types of DBMS. So, whether did you mean how many different commercial DBMS systems, or what are the different models. So, since I could not understand that, so I have just given the answer here, assuming that you are looking for different kinds of DBMS systems which are based on various different models. So, what we have done here significantly is the relational database management system, but there have been other models like hierarchical data management system, network data management system. Extending the relational, there have been object oriented database systems, and of late there has been a lot of graph databases. Since our course is a first level course on DBMS, we have just focused on the most common and most widely used DBMSs, which are the relational DBMSs. Relational schema. One clarification about relational schema, there is a set theory part. Please go back and read the module, listen to the video. Such generic questions have already been answered and cannot be discussed here. The role of a DBA, this is an interesting question. I do not know who is asking this, the name is not given here. This is an interesting question, because certainly you are attending this course mean that you are not an expert in database, and you are asking for the role of a DBA. You become a DBA after about at least 7, 8 to 10 years of experience in the database field. So, I do not know how relevant this answer would be for you right now, but just for record, I have put in all the different roles that the DBA do. Unfortunately, quite a few of them are been beyond the beyond the syllabus or the scope of this course. So, we have not had opportunity to explain them, like capacity planning, like installation, deployment issues, configuration issues. So, those are the troubleshooting issues, deep security issues. So, those are all things that DBA has to do, besides doing a usual maybe database architecture design issues and so on. Certainly, a DBA's role is at a higher level. So, the DBA is not expect, I mean DBA will have skills in terms of writing queries well, or writing small database designs well, but that is not what DBA should normally be doing. It is a very heavy role. The DBA also has to take care of the regular backup, data recovery and all those issues. Data integrity, again we have discussed this. I do not know why you always ask questions which are very generic. I mean it does not help the whole discussion. It is there in the lecture material, it is there in the video, you could just refer to that. Just to remind you, there are 4 types of data integrity that needs to be looked at regularly. One is row integrity, which ensures that all rows in the table must have a unique identifier which can differentiate the rows, otherwise you will not be able to get back the row, there has to be the uniqueness. It ensures that there is integrity of the columns, that is every column entails data of the same type, of the same length, there is default value of data if required, if this the null condition, whether you allow null data, null values or you do not, whether you allow duplicates or not, those kind of integrity questions. Referential integrity primarily talks about the foreign key. So, if you have in a table a particular field is a foreign key and it has a certain value, then this foreign key must be a primary key in some other table. So, in that table the value that you are finding in your table must be present. If there is a situation that in your table the data exists in the foreign key field and that value does not exist in the primary in the table where this is a primary key, then certainly you have integrity issues. So, you have a value from saying okay, this is this particular roll number has attended this course and got this marks, but when you go to the students table you find that there is no one with that roll number, then certainly we have integrity problems. This cannot happen. So, these are called the referential integrity, and just referring back to the question on foreign key as to why we need this referential integrity is one of the major reasons why we need the foreign key to be explicitly specified, so that the same can be checked for. Then besides that, there could be several user defined integrity rules for checking constraints. For example, I can say okay, in my database I know well nobody will be more than 15 years old. In my database I know that no property will cost more than 10 crores and so on. So, I could have variety of different user defined constraints. So, with those constraints any data or any record which violates one or more of those constraints will not be allowed to be entered, inserted or updated in that database. Application, I like to ask use of database and connectivity of it. I am not sure Shashwat Kumar whether you are asking 2 parts, that where you would like to ask about the use of database, or you are trying to ask that you would like to ask the use of connectivity for database. If you are asking the first the use of database, then please refer to the very early discussion in the course where we have discussed in depth as to why people had to move from a file system based data management to a more formal database system, which has lot of reasons in terms of being able to query easily, being able to manage big volumes, being able to maintain integrity and so on and so forth. Please go through that. If you are asking that what is the use of having database connectivity, certainly you will find that again more in the place where we have discussed about application architecture. So, if you are writing any application, a web based or a non web based application, then naturally there is certain front end which decides in terms of how you input data, how you get the final output, and then you have some logic to perform in terms of what are you trying to find out. You may have to do some computations there, and then you will have to set a right query on the database to get the results, right. So, this logically have to be the steps. Now, often, so when you want to query that database, when you want to get some information from that database, you cannot access that just as a component of your software, because it's, first of all, it's just too huge a system. Then it is used by multiple people, so you cannot take control of that. So it has a kind of loosely coupled distributed structure, where you can send a connection request, kind of a remote login, as you say, kind of a connection request, and set up a communication between the database and your application. So if you were only writing direct SQL queries on the database system, possibly you will not. You may manage without having connections, but if you want applications, it is a must. Even in many of the direct query systems, the connections are a must, because databases often, when they get large, they do not remain localized in a single server. They could be in multiple servers, and then again they need the connection protocols to exchange information between them. So things like ODBC, JDBC are ways to do that. Career, how to become a professional in database management system. Adesh, you start working, that is it. You start working, be with it, try to do well, and you will have a career progress. I mean, there is nothing, I mean, this profession is nothing specifically different from any other computer science or engineering profession. So you get started, normally you will start at a programmer level. So you become an application programmer or a SQL programmer, and then slowly grow up, start learning more, and taking higher and higher orders of responsibility, and you will be able to have a career. Saket, how will scientists think? That is a philosophical question. So keep thinking. I am not a scientist, I am an engineer, so I do not really know the answer to this. You will have to find out for yourself. Sir, I have a mistake, I have not paid exam fee. I cannot handle admin questions, you have to ask NPTEL office. Is there a easy way to understand DBMS lesson? Pavani, there is no easy way, there is no free lunch in life, Pavani. There is no easy way to do anything which is which has a good reward. So if you have to understand database well, you have to first study the DBMS well. You will have to do a lot of practice. It is an engineering subject, it is a practice oriented subject. So you have to take different situations and design the databases for them, the tables, attributes, the different analysis, functional dependencies, normalization, what is the effect of normalization and all that. Then you will have to practice coding for several queries, and not only like any other programming exercise, it is not enough to just write the query on paper. You have to actually populate data in a live system or in a pseudo live system and try out the query. So it is only very thorough hard working that you can become master of DBMS. I am sorry, there is really no shortcut to that. Practical experience, Snehandu Chanda. So what do you mean by practical experience? Is how to get practical experience, or I mean, it's again not clear, but we have given the link to a live server, Oracle Live SQL server, where you can quickly create your own data set and run different queries to check for correctness and make your learning faster. I think we had mentioned this during the course as well, but you can refer to from here. How are data arranged in cloud computing? Its cloud computing is a significantly different concept. It does of course have a database behind. The question is from Santosh Raj, and they use a variety of databases. A large number of, as far as I know, cloud computing platforms use different forms of relational databases. So some names are given here. Voice is not clear to understand, please talk to NPTEL office, but before that check your system. It's these videos are very heavily quality checked. So if you are having a voice problem, then in most likelihood you have a difficulty in either your data has not been properly downloaded or there is some issue with your system. Cloud computing is another alternative to database. No, I mean these are two different concepts altogether. In cloud computing, all that you say that normally if you want to do some exercise, and cloud computing is not limited to database applications. I mean it is all kinds of applications can be on the cloud. So, what is a cloud is just a conceptual tag. All that you are saying is in a normal environment, if you have to do some experiments, if you have to develop programs, maintain data, execute programs, you need to have direct access to the server which keeps your data, which keeps your program, which keeps your libraries, where you build and do all that. So, that is a physical system. So, now cloud is nothing but a virtualization of that physical system. So, it is a kind of entry gateway through which you log into the system. You may not physically know where your computing servers are, you may not physically know where your database servers are, you may not know where your data is residing, but all that you can do is through this soft interface, the remote interface, you can actually work with the data, execute your compute and so on. So, cloud could be in terms of a very tightly coupled local network system, it could be in terms of public network, in terms of private network, it could be heavily distributed across the world, it could be a service provided by a specific company. So, these are different aspects, and many of those concepts have to deal with lot of aspects of distributed systems which we are not covering here, like all these different kinds of services like SAS, you must have SAS and PaaS, at least you must have heard of. So, they do at the back use database. So, cloud, I would say cloud computing platform is more like a hyper application on the database systems, using which you could develop other applications, but that per se is not a topic in the core of the at least this level of database system course. Then I have Gade Sahitya Kirani. What should we learn for database management? Is only SQL enough? Certainly not, certainly not. If only SQL were enough, we would not have spent so much time in terms of discussing the design aspects, discussing the physical structure, discussing the transactions and concurrency. Those are very, very critical, and you must learn all of that. Certainly, SQL language and SQL programming is very important, and it is the starting point of working with a database system even before you have gained expertise in the other areas, and you would see that we have a significant amount of modules and time dedicated to SQL, because that is the starting point. So, certainly I want that all of you should be very, very solid in terms of SQL, but do pay attention to the design aspects as a modeling and design aspect as the next step. Then in terms of the physical characteristics, the data representation, physical representation layer and so on, how do you build applications and so on, and subsequently in terms of the transactions, concurrency, recovery, those kind of issues, but everything that as discussed is important. In fact, there are a number of important concepts which we have not been able to discuss because of the shortage of time that we have. What kind of questions can I tell? I think you meant ask. You can ask questions that relate to your course, applications, database, miscellaneous queries, like some asked on career and current technology and so on. And you should never ask questions on administration, because I cannot answer that. I am not a part of administration of the course. Ask that to NPTEL office, and it does not help if you ask unspecific questions, because they cannot be answered. So, here we are doing the live session to answer very specific questions which are not accurately addressed in terms of the presentation and the video. So, ask such pointed question. In this world of moderation, most actively used is a graph model for user social networking. How do such processing work behind the scene? I'm sorry, I'm not being able to pronounce it. Avipsit possibly Chaudhuri. So, here what you ask is a very, very deep question, and this is first of all not again in the purview of the database management system. Graph databases or networks or often they are called complex networks. Don't get confused with the computer network. They are, besides the concept of networking, almost nothing is similar between them. Are huge graphs which need to be represented and searched and so on, where the at least at the top level, the typical modeling of the relational style or those theories do not play a very significant role. They do not. I mean they play a role, but they are not the critical component. There are several other components like flexibility, like associativity of information. This is common. So it's a subject by itself. So hardly I can do any justice discussing that. You should look for courses on, I think the NPTEL NOC courses on social networking, complex networks, things like that. If you are interested, you look up for those courses and attend them. They are really rewarding experience. Okay. So I think in terms of the questions that we had, we are at the end. I will just take from Srijani if there are some questions that are worth answering from the online inputs that I have got. So, were you part of the team which designed database for National Digital Library of India? Can you share your experience and challenges faced by and the technology used? Ashok, this is an interesting question. I mean, I'm a part of the team, but I'm pretty high up in the team. I'm the project leader. So I deal with things at a much conceptual level in NDLI. There's a faculty lead, Professor Plavan Kumar Bhaumik, who is from our IIT Kharagpur itself. Probably he also offers some courses, who has actually done the design. It's a heavily distributed design, and it's not at the back end it uses a DBMS. So in parts it uses your MySQL and what is that, Postgres partly, because we have a strong mandate to have everything on the open source in this project. So we don't use any commercial software. So the database, but a much of it is National Digital Library of India has to deal with our networked information, associative information. So we use a whole lot of search engines on this, which are somewhat of a very different, significantly different concept from the database system. This is not the right platform to share the experience, but well, I'll keep this in mind. At times we do webinars from NDLI. So if we, and those are normally publicized through our NDLI's Facebook page. So next time we do, we will try to talk about these experiences, and you can stay tuned on that. Okay. Practical use of normalization and transaction system, Dr. V.K. Verma. Normalization, it's a huge topic. So you have you please go through that. The basic issue of normalization, even earlier in today's discussion, I have talked of that you need to normalize so that you can minimize the redundancy in the database. You need to normalize so that you can minimize the possibilities of anomaly in the database. You need to normalize so that it becomes easier to maintain the integrity of the database. You need to normalize so that you can optimize in terms of the query as well as space. So there are answers, and the reasons are several, and you will have to again go through those slides maybe or presentations to understand more of this. Transaction systems are I think the question is not very well formed, because practical use, this is an engineering subject. So an engineering subject does not do theoretical things. So anything that you deal with, if something which is not practical or it's more towards the theory, then we just don't discuss it after a while. So we are talking only about things that of use. In transaction systems are basically are critical to decide that how does the different changes. So there are three basic things you can do. You can insert a new data, you can update an existing data or you can delete a data. So, these are the ways your database can change, and what you can do, you can query the database where you do not change, but you get some information out. So, that is, I mean, every application finally are these 4. So, any kind of small or micro level operation that you do to achieve any one of these is a transaction, which either takes some information or makes some changes in the database. So, transactions are the core of why you are doing the database, because you want to maintain the information, you want to track the information, you want to change the information. So, and the transaction systems become critical not only because of their nature, but because of their volume. You are doing database because so that million transactions can happen, and they can happen from thousands of places by hundreds of thousands of people for maybe hundreds of different requirements and so on. So, that is the reason you need to understand this very well. How to identify current transaction life cycle? Pratik, I did not really understand this well. What is meant by, what you mean by current transaction life cycle? If you are talking about online tracking the heartbeating of the database system, we have not discussed that, because we could not keep that in the scope. There are different tracking facilities available, which tells you how the transactions are doing in terms of how many transactions are live, the state of every transaction, as to the turnaround time of the transactions and so on, if there is a bottleneck in the transaction and all that. That is kind of more of an administrative management of databases, which we could not cover in this course. So, we do not have that answer. Why payment is taken as weak entity? It can have attribute as PID of its own that can distinguish for each payment. I just do not know, because you have not specified what is the table, what are the dependencies and so on. So, how do I know what is a payment, where, whose payment, in where you are saying it is weak entity set is inspecific. So, I cannot answer, Amish, I am sorry. Explain extendable hashing. This is something which is a very detailed procedure. It is there in the slide. I do not think this is really outside of what we have already discussed. Akshat, anything else, Himadri, Shayani, yes, Srijani? Huh? Okay, then I think that's all we had for the session today. I hope this will help at least in some of the aspects. I am sorry I could not explain everything again in detail, but I will reiterate again that to be able to do well, you please go through the videos very carefully. I mean, if you have asked these questions, if you have not asked these questions, there are live session videos available from previous runs of the course also. You could look up those questions and answers, and focus very clearly on first on SQL. You must be good in writing queries, next on the design aspects in terms of functional dependencies, normal forms, how to do design, normalization and so on. Next in terms of the physical database design, then in terms of the transaction concurrency aspects. So, do them very thoroughly, revisit the assignments, all of them in terms of the solutions and explanations that have been given, so that you make sure that you understand them well. As you know, quite a bit of what exists in the video and the lecture is also asked in the final written question paper. Quite a bit of part comes from the assignment itself, and then you have new problems. So, and finally, you must concentrate on trying out different queries, use the live system, try out different queries, so that you can get better confidence. So, thank you all very much for your attention, and I wish you all a very, very good experience with the examination. I wish you all the luck for it. Thank you.